In this section, we're going to study how to determine the intervals on which the function is increasing and decreasing by using the derivative. Here are the goals of this section. The first one is why does the derivative of a function tell us whether the function is increasing or decreasing? And the second one is how do we find local maximums and minimums using the first derivative test. And the third one is to know how to sketch a graph of a function with information from the derivative of that function. Okay, let's first talk about what are the intervals of increase and decrease. So specifically, what does it mean for a function to be increasing or decreasing on an interval? Here is the definition. The function f(x) is increasing on the interval I if for any pair of numbers x1 and x2 in the interval I, where x2 greater than x1 implies f of x2 is greater than the function value f of x1. And function is decreasing on the interval I if for any pair of numbers x1 and x2 in the interval I, where x2 is greater than x1 implies the function value at x2 is less than the function value at x1. So here is an example. Here we have two functions, and for the first function, if we consider two random x values, okay, so this is x1 and this is x2. Now we can see x2 is greater than x1, right? Now let's look at their function value. The function value at x2 is this, and the function value at x1 is this. Now, because f of x2 is greater than f of x1, so this function is the function f(x) is increasing on this interval. Okay, and the same thing for this function. Now here is x1 and here's x2. The function value at x2 is this, and the function value at x1 is this. So f of x2 greater than f of x1. So these two functions, they are both increasing. Okay. Now let's look at the examples of decreasing functions. Here x1 is less than x2, but the function value at x1 is greater than the function value at x2. So according to the definition, this function is decreasing. This function is also decreasing. Okay, now an informal way to think the definition of increasing and decreasing function is so when we trace on the x-axis from the left to the right, okay, if the graph it goes up from the left to the right, then the function is increasing. Okay, like here, when I trace on the x-axis from the left side to the right side, now during this process, the graph it rises up from the left side to the right side, so the function is increasing. If it's the opposite, if the graph it goes down from the left to the right, as I'm tracing on the x-axis, then the function is a decreasing, like here. So when I move from this side to this side, during this process, the graph it goes down. Okay. Let's see another example. Okay. So this function, it is increasing from negative infinity to -1, and it is decreasing from -1 to +1, and it is increasing from +1 to positive infinity. Now here, please remember that when we are talking about the interval on which the function is increasing or decreasing, we are talking about the x values, not the y values. Okay, so as you can see, why the function is increasing from negative infinity to -1, because when I trace on this way, when I move from negative infinity to -1, the graph, it rises, right? The graph, it rises. And when I trace from, when I move from -1 to +1, the graph, it goes down. And when I move from 1 toward to positive infinity, the graph, it goes up again. Okay, so that's why this function has two intervals of increase and one interval of decrease. Okay, now let's talk about, let's see how can we relate this property to the derivative. Okay, let's go back to this graph. Now we know that this function is increasing on this interval, right? Let's consider any random x values. Let's consider any random x values on this interval. For example, let's see here. Okay, and let's see what is the derivative of this x. Now, to see what is the derivative of this x, we need to think about what is the slope of the tangent line at this point. Okay. Now the slope of the tangent line at this point, the tangent line looks like this, right? So this from this tangent line, we can see that the derivative is a positive. Why? Because the tangent line, it goes up from the left to the right. So the slope must be a positive numbers. Okay. Let's look at another one. Let's say another x. Okay. Now at this point, the tangent line, it looks like this, which is also positive. Okay, and you can see this is true for any x on this interval. Their tangent lines, the slope of their tangent lines are all positive, So here we can say when the function is increasing at x, that means if we want to compare with the derivative and 0, the derivative gonna be positive, gonna be greater than 0. Okay, let's look at if what happens if the function is increasing. Sorry, if the function is decreasing. So let's look at the x here. So I draw a tangent line at this point, and looks like this, right? So because the tangent line, it goes down from the left to the right, so the slope gonna be a negative numbers. Therefore, the derivative gonna be less than 0, and this is true for every x, for every point on this interval. Their tangent line, their tangent lines, they all have a negative slope. Okay. So this is less than 0. Okay, let's look at another example. So we can see on the graph, the function has two intervals of increase. One is from -infinity to -4, and one is from +3 to positive infinity. And the function has one interval of decrease, which is from -4 to +3. Let's see what happened to their derivatives. Okay. So on this interval, on the interval of increase from -infinity to -4, at each point, the slope of the tangent line is m, and we can see the the slopes are all positive numbers, right? Like here, when x equals -8, the slope of the tangent line is 258. It's positive. When x equals -6, it's 96 positive. However, on the interval of decrease, the slopes are all negative, right? They are all negatives. And when becomes the interval of increase, the slopes becomes positive. So in this example, we're given a function defined on the interval from 1 to 7. The function is decreasing on the interval from 1 to 4. Since the function is decreasing on this interval, so the derivative is negative on the interval from 1 to 4. And the function is increasing on the interval from 4 to 7. Since the function is increasing, the derivatives are all positives on this interval, right? Because if we draw the tangent line, they're gonna look like this. For any tangent lines on the interval from 1 to 4, their slopes are all negative. And for any tangent lines on the interval from 4 to 7, their slopes are all positives.